All right, today we're going to jump ahead to 9.12. And I think you'll see why I'm jumping ahead and then coming back to 9.11 by the end of the lecture. But 9.12 is just about the sum and difference formulas for sine and cosine. Okay? And there they are. Ta-da! They're there for you to use. And you will be given these formulas on the exam. So you don't have to memorize them. Now, that's it for the lecture for today. So here's the formulas, right? I'm not going to go through the derivation of the formulas. There's a derivation in your book. There's also other ways you can derive these formulas using the distance formula. But I'm not going to go through it. It's kind of long and involved, and I don't think it's necessary for you to be able to do the problems that you're going to be assigned to do. So you're just going to need to be able to use these formulas. So let's go ahead and do some of that. All right, so this first problem, we want to find the exact value for the cosine of 15 degrees. Now let's see, can I have both of these on the screen at the same time? All right, I guess you can see part of it anyway. So now 15 degrees is not an angle that we know. And it does say find the exact value, okay? So that's important. That means you're not going to give me a decimal approximation. You're going to give me an exact value. So we have to figure out a way to find the cosine of 15 degrees using the angles that we know. Angles like 0, 30, 45, 60, 90, and so on. Any other angles that have reference angles of 30, 45, or 60. We know those, and because you were able to fill out that unit circle, so you know them. So let's think about a way that we could express 15 as a combination of some of the angles that we know. So one example is that we could do the cosine of 45 degrees minus 15 degrees. Okay, 45 degrees minus 15. Oops, what am I saying? 45 degrees minus 30. What am I getting? Let me erase that. 45 degrees minus 30. That's what I meant to say. 30. Okay, that would give us 15 degrees. All right. Another way that we could do it is we could express it in terms of the 60-degree angle and the 45-degree angle. So 60 minus 45 is 15 as well. So you could use either one of those. There's probably other ways as well. But let's try expressing. Let's just try the first one. Let's do the cosine of 45 degrees minus 30. Okay. So I'm going to come up here to the sum and difference formulas. You can see this one here. Cosine of theta plus phi is cosine of theta times cosine of phi plus sine of theta times sine of phi. Okay. Now in this case, the first angle, theta, is 45 degrees, and the second angle, which is phi, is 30 degrees. So we're just going to substitute those values in. So cosine of theta, which is 45 degrees, times cosine of 30, which is phi, and then it's a plus, right? So you see there's a plus here. It goes with the minus, so it's plus sine of 45 degrees and sine of 30. Okay, so we know the exact values of all of those cosine and sine values. So I don't know. I'm not good at memorizing, but if I visualize it, I know it. Okay, so I'm just going to draw the unit circle. I know that 30 degrees. I'm just going to draw an angle in here. We'll say that's 30 degrees. And those coordinates, which are the cosine and the sine, are square root 3 over 2, comma, 1/2, right? Those are the coordinates which give us the cosine, square root 3 over 2, and the sine, which is 1/2. Okay, so that's 30 degrees, and if I want 45 degrees, let me draw that one in. And the coordinates there are square root 2 over 2 and square root 2 over 2. Okay, so now let's just substitute those values. The cosine of 45 degrees is a square root 2 over 2. Cosine of 30 degrees, okay, remember it's the x-coordinate, so it's a square root 3 over 2, plus the sine of 45 degrees, which is square root 2 over 2, times the sine of 30 degrees, which is 1/2. Okay? So if I multiply this together, I can take square root 2 times square root 3, I get square root 6. Combine those under the square root. Okay, and if I multiply the denominators, I get 4. And I can combine these two, I get square root 2 times 1, which is just square root 2 over 4. And I can rewrite that as square root 6 plus square root 2 over 4. And that's it. That's as simple as I can get it. I cannot combine the square root 6 and the square root 2. Okay, so be careful about that. Don't try to combine that. It's not square root 8. So you just have to leave it. Square root 6 plus square root 2. All right? And there we go. Now we could put this in our calculator and get a decimal approximation. It comes out to be about 0.9659. Okay? That's approximately. But it doesn't ask for that. It asks for the exact value. And if you want the exact value, it's this expression in terms of the square root 6 and the square root 2. All right, let's try another example. Okay. I'm just going to go down here. Okay. Find an identity for the sine of 2 theta in terms of sine and cosine. All right. So here's the trick to this one. Now, this is actually why I'm presenting the sum and difference formulas today and then going back to 9/11, because 9/11 they talk about the double angle formulas, which I don't understand why they would present that first, because it's so simple to figure out the double angle formulas from the sum and difference formulas. Okay, so let me show you how we can do that. The sine of 2 theta is equal to the sine of theta plus theta, right? Theta plus theta is 2 theta. And now I can use the sum and difference formulas, right? Only the angle theta is theta and the angle phi is also theta. So I'm just going to substitute theta in for each angle. All right, so we need the sum formula for sine. All right, we can go back up here. It'd be nice to have this on the side, or I could just keep it. But you can see we're going to use this first formula right here. Okay, I'm just going to use that one. All right, so let me just go scroll it down here and oops. All right, we'll write it out. Okay, so it's the sine of theta, cosine of phi, which is also theta, cosine theta, plus the cosine of theta sine of phi, which is also theta. Okay, so we just, instead of phi, we got theta. All right, now if you look at those, multiplication is commutative. Okay, so I could rewrite this one over here as sine theta, cosine theta, right? And then I have 2 sine theta, cosine theta. Okay? So there you go. That's your identity, your double angle identity. Sine of 2 theta is equal to 2 sine theta, cosine theta. Okay? I'm going to put a little box around that. Okay, we're going to use that again on Friday. But there you go. You've got it. That's the double angle formula. All right, let's try some more here. Here, let's see, I don't know if just leave it like that, I guess. Okay, so here we've got the sine. We're asked to verify this identity here. Now, this is something it gave you. I'm trying to remember what it was, like 9.7. It was in 0.997. You know, basically that just showing that the sine function is the cosine function with a horizontal translation of pi over 2. Okay, we showed it graphically, but now we can actually use the sum and difference formulas to verify this as well. So we want the difference formula for cosine. Okay, so again, I wish I had this on the side. I could just point to it, but I suppose I can scroll up. So we've got a difference for cosine, right? So we're going to use the same one that we did before, this cosine theta minus phi. All right. So if you've got your paper in front of you, you'll be able to see this better. All right, so we're going to take the cosine. Oops, and make it nicer. We're going to take the cosine of t times the cosine of pi over 2 plus the sine of t times the sine of pi over 2. So that's just the difference formula with t substituted for theta and pi over 2 substituted for phi. Okay. Now we know that the cosine of pi over 2, let me first of all just copy this down. Cosine of pi over 2, if I were to draw my little unit circle, pi over 2 is at 90 degrees. And the cosine up here is 0. And the sine is 1, right? So let's substitute that in. Cosine of pi over 2 is 0. Okay. Sine t, and then the sine of pi over 2 is 1. Okay. So this thing goes away. Anything times 0 is 0. All right. So then we can just simplify it down to sine of t. All right, which is what we were asked to do. So now we've shown that the cosine of t minus pi over 2 is sine of t. All right, now let's go to the next one. Okay. Okay, so now here we're not given angles. We're given the sine of alpha and told that it is in the first quadrant. And we're given the sine of beta and told that it's in the second quadrant. Okay, so now in order to find cosine alpha plus beta, we can just copy down that sum formula. So it's cosine alpha cosine beta minus sine of alpha sine of beta, right? So we have the sine values, but we need the cosine values as well. So I'm going to use the unit circle to figure this out. So I'm going to draw a little unit circle, and we're told that the first angle is in the first quadrant, right? So that means that I have an angle in which, let me just draw this angle in here, in which the sine, which is the distance above the x-axis, the y value of the coordinate, is equal to 3/5. Okay, so that side length is 3/5, and the hypotenuse is 1 because it's a unit circle. Okay, so let's find the cosine value, which is this leg of the triangle. Okay, and it's a right triangle, right? Okay, so we can use the Pythagorean theorem for this one. So we can take the hypotenuse squared, which is just 1, minus the leg squared, which is going to be 9 over 25. And if I take the square root of it, I will get the length of that leg, that horizontal leg. So I get when I do that. This one can be written as 25/25. So then I can rewrite it as 25 minus 9, which is 16 over 25. Okay, and again, the square root of that. And, of course, those are perfect squares, so I get 4/5. Okay. All right, so that's telling me the cosine of alpha. Okay, so this is angle alpha. Should have made that bigger, but that's angle alpha. And this is the cosine. Cosine of alpha. All right, so now let's find the cosine of beta. So we're given the sine of beta. Okay, so I'm going to draw another unit circle. All right, oops, what's going on here? Oh, I got the eraser on. There we go. Okay, okay, draw another unit circle. There's my axes. And we're told the sine of beta is 5/13. And it lies in the second quadrant. Okay, so it's over here in the second quadrant. So I'm going to draw a little angle over here. Let me see if I can draw this. Okay. So we can draw this little triangle. Imagine that's a right triangle. Okay. Where the sine, which is this vertical distance here, is 5/13. 5/13. Okay. And, of course, the radius is 1 because it's a unit circle. And we just need to find the horizontal distance, this leg right here. Okay. And again, we can use the Pythagorean theorem. Now we have to keep in mind, though, that now we're in the second quadrant, so the cosine is negative in that quadrant. Okay, so we're going to get the negative square root of 1 squared, the hypotenuse, minus 25/13 squared, which is, 5/13 squared, which is 25 over 169. Okay, and then we can simplify that. We're going to again get the negative square root. Now 169 over 169 minus 25 over 169 gives us 144 over 169, and that is negative 12/13. Negative 12/13. All right, so that is our cosine of beta. Negative 12/13, because we're in the second quadrant. All right, so now that we have cosine of alpha and cosine beta, we were given sines for alpha and beta. Now we just need to plug it into the formula here. All right, so cosine of alpha is 4/5. Okay, cosine of beta is negative 12/13 minus sine of alpha, which is 3/5. That's what we were given. And the sine of beta is 5/13. Okay. All right, now when I do this, I'm not going to do any cross canceling here because, I mean, I could cancel 5 with 5, but I want the same denominator, and if I take 5 times 13, I'll get the same denominator. So let's just do that, the arithmetic now. So I get a minus 48 over 5 times 13, which is 65, minus 15 over 65. All right. So if I add the numerators up, I get a minus 63 over 65. So that's my answer. That is the cosine of the sum of those two angles. All right, let's keep going. I guess this is, I suppose, where you can pause the video and work on these practice problems. A lot of these problems are very much like the homework problems, so I recommend that you do them now so that you're prepared. And then you can come back and watch the solutions once you're done. All right, so let's take a look at this first one. we're given the values of sine and cosine for angle A, and we're given the sine and cosine for angle B, and we're just asked to find the sine of the sum, the sine of the difference, and then down here we're asked to find the cosine of the sum and the cosine of the difference. So this is just straightforward application of the formula. Okay, so the sine of a sum is the sine of A cosine of B plus cosine of A sine of B. So again, you don't have to memorize these. Just have your sheet out in front of you, and just make the substitutions for the angles. Okay, so now we're given those values. Sine of A is 0.5878. So we just substitute that. Cosine of B, okay, given the cosine of B is 0.9781 plus cosine of A, we're given that 0.8090 times 0.2079. Okay, and then it's just a matter of putting it into your calculator. I put it in my calculator, I get 0.7431. Okay? Next problem is very similar. Now the difference formula for sine is basically the same as the sum formula, except it has a minus in the middle. Okay? So if you have like a TI-84 where you've already typed in all of these values, all you need to do is recall that expression that you just typed in and change the plus to a minus. Okay, so I'm going to do the substitutions here. It's the same numbers, 0.5878 times 0.9781, and it's going to be minus, what is it, 0.8090 and 0.2079. Okay, just substituting in. I didn't write out the whole equation this time, but it's the same as this equation up here, only with a minus. And then just put it in your calculator. 0.4067 is what I got. All right, let's go on to the next two. Again, we have the same values. Ooh. I guess I'll leave it like that. We have the same values for the sine of A, cosine of A, sine B, cosine B. Now we're just trying to find the cosine of the sum of these two angles. Okay, so I'm going to write out the sum formula first. It's the cosine of A, cosine of B, minus sine of A, sine of B. So for the cosine of a sum, we're taking the difference of these two. So notice it's a minus. Okay, but again, you don't have to memorize these formulas, so just be sure to look it up. Okay, so I'm just going to substitute these values in from problem statement. 0.9781 is the cosine of B. The sine of A, I've got 0.5878 times 0.2079. Put it in my calculator, and I got 0.6691. All right, now we're asked to find the cosine of the difference of angles A and B. All right, and the cosine for a difference is the same formula as for the sum, except it has a plus in the middle. Okay, so we get the same values, 0.8090, 0.9781, but now we're going to change this to a plus. Okay, 0.5878 and 0.2079. All right, put it in your calculator, and I got 0.9135. All right. Pretty straightforward. Let's go down here to these. This next problem, there's 3 parts to it. Now, there's a number of problems, I think, in the homework like this, where you may be given the sum of 2 angles, or you just might be told to find the sine of, say, 255 degrees, and you have to figure out what angles you know that will give you an exact. Now notice it says exact. We want exact, not a decimal approximation. So we're going to use the angles that we know from the unit circle, and figure out an angle that we don't know. Okay, so but here we're given how to break 255 up, right? We can break it up into 210 plus 45. And we know the sine and cosine of 210 because it's just 30 degrees beyond 180, right? So it has a reference angle of 30 degrees, but it's in the 3rd quadrant. Okay, let's actually draw that. Let's actually draw where these angles are. So I always like to visualize these things. Okay, so of course you know where 45 degrees is. It's just right here. And we know the coordinates are square root 2 over 2, comma, square root 2 over 2. Okay, so those are our cosine and sine values. 210 is over here. My circle's kind of lopsided, but you get the idea. It's over here. And the coordinates in the 3rd quadrant are both negative, so we have minus square root 3 over 2, comma, minus 1/2. Okay, so now we have the sine and cosine of those 2 angles, and then it's just a matter of plugging the values into the formula. Okay, so we're going to do the sine of 210, cosine of 45 degrees, plus the cosine of 210, sine of 45 degrees. All right, so we're going to plug in the values. The sine of 210, okay, that's going to be the y-coordinate, so minus 1/2. Cosine of 45 degrees, square root 2 over 2, plus cosine of 210, right? That's a negative square root 3 over 2, times square root 2 over 2. Okay, so now we just have to do the arithmetic. Now we want the exact answer, so we're not going to put this in our calculator. I'm going to take 1 times the square root of 2, it was negative 1 times the square root of 2, so we get a negative square root 2 in the numerator. 2 times 2 is 4, so that gives you, that's the first term. And then we've got a negative here, so I'm just going to make it minus. Square root 3 times the square root 2 is the square root 6 over 4, which we can also write as, I'll just make it like this, negative of the square root 2 plus the square root 6 over 4. So it's a negative of that whole quantity. I could write it that way. This is fine too. The first way I read it is fine. I think if you entered something like that into Wiley plus, it would work. All right, so here's another one. It's very similar, only we're doing the cosine of a difference. And again, let's take a look at where these angles are. These are angles that we know. Whoops. All right, my circle is not looking good, so I'm going to start over. All right, let me try and draw a circle again. There we go. And axes that are crooked, but that's okay. All right, so again, we got a 45-degree angle. That second one is 45, and we know the coordinates are square root 2 over 2, comma, square root 2 over 2. And we have 300 degrees. Now, 300 degrees is 60 degrees shy of 360. So the reference angle is 60 degrees, and it's down here in the 4th quadrant, down here. Coordinates in the 4th quadrant, the x is positive and the y is negative. So you can see that the cosine value is 1/2, positive 1/2, and the sine value is negative square root 3 over 2. Okay. And then we just have to use the formula and plug in the values, right? So if we're going to use 300 minus 45, we're going to take the difference formula for cosine. So we get the cosine of 300 degrees, cosine of 45 degrees, plus the sine of 300 degrees, sine of 45 degrees. And we've got all of those values. So cosine of 300 is 1/2. Cosine 45, square root 2 over 2. Sine of 300 is minus square root 3 over 2. Times the sine of 45, which is the square root 2 over 2. Okay. Then we just need to combine all of that. So we get square root 2 over 4. Okay, plus, well, it's plus a negative, so I'm going to make that minus. Okay, so I'm going to do minus square root 6 over 4. And I can also write that as square root 2 minus square root 6 all over 4. All right, got one more here in this set. All right, well, in this particular problem number 2. All right, so now this one we're not given the how to break it up. So we got choices to make. Probably the most obvious would just be to break it up as the cosine of 300 plus 45. Okay. Now, that's not the only way, but that's one way we can do it. So, let's just do that. I'm going to, again, draw my unit circle because I like to visualize things. I need it. I don't have these, do not have these memorized, cosine of 300, but I do know that it has a reference angle of 60 degrees, and I know that it's in the fourth quadrant. So if I draw it, then I can visualize where I'm at. So I guess it's the same as above. Actually, both of these angles are the same as above, aren't they? So I really don't have to redraw this, but I will. I've got to get it started. So, I started out with 300. So the cosine of 300 degrees is 1/2, and the sine is negative square root 3 over 2. Up here at 45 degrees, the cosine is the square root 2 over 2, and the sine is square root 2 over 2. Okay, same as above. I really didn't need to redraw it, but I did. All right, so let's plug it into the formula. So the formula is basically the same as the one above, only with the minus in the middle. So it's the cosine of 300, cosine of 45, minus the sine of 300, the sine of 45. Okay. So, again, we'll just plug in the values. We get 1/2 times square root 2 over 2 minus, okay, the sine of 300 is negative square root 3 over 2 times cosine of 45, which is the square root 2 over 2. Okay, and then we can simplify that. We get the square root 2 over 4. And then we have minus a negative, so I'm going to make that a plus, square root 6 over 4. Okay, and I can rewrite that as square root 2 plus square root 6 over 4. Okay. Now I want you to notice something. This, if you go back to example 1, this is the same answer that we got for example 1. Okay, so, and if you think about it, this 345 degrees is just 15 degrees shy of 360, right? So if I were to draw that in here, let me just draw that. So here's about 345 degrees, and the reference angle is 15 degrees. Now, in example 1, we found the cosine of 15 degrees, right? And so if we could have gone just back to example 1 and said, well, the cosine of 15 degrees is going to be the same as the cosine of 345 degrees because they're both on that positive side of the x-axis. So we could have just gone back and looked at example 1 and copied the answer and not gone through all of this. So, so I'm just noting that as an aside. All right. So, we got, is this the last one? I think this is the last one here. All right, that's good. We want to use the sum and difference formulas to verify this identity right here. So this is a lot like the example in the lecture. So we can just use the sum formula for sine and figure this out. All right, so we've got t plus pi over 2. So when we use the sine sum formula for sine, we have the sine of t times the cosine of pi over 2 plus the cosine of t times the sine of pi over 2. Okay? Now, pi over 2, you remember, I'll just try it over here this time. Pi over 2 is 90 degrees. The coordinates at 90 degrees are 0, 1, right? So the cosine is 0, and the sine is 1. All right, so we get sine t times 0, right? Because the cosine is 0, plus cosine t times 1, which anything times 0 is 0. Just cancel that out. And we just, 1 times cosine t is just cosine t. And there you go. We're set.